Hi Virginia, I have the problem that you sent me here. I took a photo of it, and I'm just going to go through that briefly so that you can see what to do with it. Okay, so the first thing you want to do is identify which things are going to be substituted into the formula. This number here is S, and so that's going to go right here in the bottom of the equation. S1 is the solar constant at any given date. That's your S1 there. So it's your unknown. That's what you're trying to solve for. So I'm going to start writing up here. I'm just going to write S1 over 1361. Okay. Equals. Now, if you look at this part of the equation, we have the two D values. And the first D value is given right here. It's 150 times 10 to the 6th. So I'm going to fill that in the top. And that's in kilometers. And on the bottom, we're going to have 152 times 10 to the 6th also. And that's also in kilometers, okay? Now this number here is in Wm to the minus 2, which is W, I think that is that watts, I'm not sure, per meter squared. So we can write the m squared on the bottom. We don't need to worry about equating the units, about having the units match, because kilometers and kilometers will cross out here, and the answer that we're going to get for S1 is going to be in this unit, which makes sense because it's measuring an S value, which is obviously measured in these W per meter squared. So what we're going to do to cross multiply is we're going to use, oh sorry, this is squared, isn't it? Okay, so let's work down here now, down at the bottom, and I am going to have S1 over 1361 equals 150 times 10 to the 6th, and that's squared, over 152 times 10 to the 6th, and that's squared. So when you do that, all you're going to do is change the exponent on, instead of 6, you're going to multiply those two exponents together and get 12. That's the exponent rules. When you have brackets between an exponent, you multiply them, okay? Or brackets between two exponents. So now what we're going to do is we're going to use a little thing that I call the Z pattern. And that's going to allow us to quickly cross multiply so that we can get the answer for S1. What we do is we start at the unknown that we're looking to solve for. That's S1 here. And we make a Z like this. So we go across and then diagonal and then down. Across this diagonal, we're going to multiply those two numbers. And the very last term is going to get divided into the answer. So let me just try to move this up a bit. Here we go. All right. And so S1 is going to be 150 times 10 to the 12 multiplied by 1361 and then divided by 152 times 10 to the 12. So I can let you put that in your calculator. The 10 to the 12 divided by 10 to the 12 is going to cross out. So we really have 150 times 1361 divided by 152, and that'll make it a lot easier for you to put into your calculator. And so when you do that, I'll quickly do a calculation for you so you can check and make sure that you're doing it right. I get 1343, and that's going to be watts per meter squared, or 1343 watts meters to the minus 2, which means the same thing. It seems like that's a reasonable answer since the first S value was 1361. Our S value is close to that and seems to be in that same sort of range, so that might make sense. And I think that's all they're asking you to do here is doing what he refers to as a bit of cross multiplying. So I hope that helps, and I look forward to working with you on Thursday.